students, good morning all of you. This is your Prabhakar and welcome to our channel Dawn of Chemistry. Welcome to our brand new mega problem series. In this mega problem 3, I have made a mega problem based on the thermodynamics. Let us see what is this problem. This is based on Carnot engine and based on specific heat and based on enthalpy of neutralization. Let us see what is this problem. X kilojoules is the work done by a Carnot engine operating between temperature 0 degrees centigrade and 200 degrees centigrade when Y kilojoules of heat is supplied to the engine. Y kilojoules is the heat required to raise the temperature of 18 kg of ice from minus 10 degrees centigrade to plus 10 degrees centigrade. If Z kilojoules is the heat liberated by mixing 3 moles of H2SO4, 3 molar H2SO4 of 2 liters with 5 molar NaOH of 1 liter. Then find X plus Y plus Z. Here our challenge is we have to find what is X. We should find what is X, what is Y and what is Z. So let me divide the problem. X kilojoules is the work done by a Carnot engine operating between temperature 0 degree and then 200 degrees centigrade when Y kilojoules of heat is supplied. This is one part. So we are supplying Y kilojoules of heat, it is doing X kilojoules of work and it is operating between 0 degree centigrade and then 200 degree centigrade. This is based on efficiency of Carnot engine. Next, Y kilojoules is the heat required to raise the temperature of 18 kg of ice from minus 10 degrees centigrade to plus 10 degrees centigrade. This is one part. This is based on the specific heat. And finally, Z is the kilojoules of heat liberated by mixing 3 moles of H2SO4 of 2 liter, 5 molar NaOH of 1 liter. This is one part. So totally this is having 3 parts. The first part is based on the efficiency of Carnot engine. The second one is based on the specific heat and third one is based on the enthalpy of neutralization. Enthalpy of neutralization. Let me tell you the formulas for first part, second part and then third part. Let us see the first part. Let me tell you. This is the first part. In this part, see, X is equals to work done, Y equals to heat supplied. Always remember, work done is equals to heat supplied into thermodynamic efficiency or efficiency of Carnot engine. So X is the work done, Y is the heat supplied and thermodynamic efficiency. You know, thermodynamic efficiency equals to T2 minus T1 by T2 will come. T2 minus T1 by T2 means T2 value is 200 and this is 0. If you convert into kelvins also, it's not going to change much. So the difference will be 200 and T2. T1 is equals to 273 Kelvin, T2 equals to 473 Kelvin. So 200 by 473. So if it is 200 by 473, what will be the value? We will find here. So Y into 200 by 473. So here the value you should know is Y. Hope you understood this part. X kilojoules is the work done by a Carnot engine operating between temperature 0 degree and then 200 degree centigrade when Y kilojoules of heat is supplied to the system. So work done is equals to heat supplied into thermodynamic efficiency. We know very well thermodynamic efficiency equals to T2 minus T1 by T2. That value is 200 by 473. So here we should know the X value and we should know the Y value. Let us find the Y value. What is this Y value? Remember this carefully. So what is this Y value means? Y kilojoules is the heat required to raise temperature of 18 kg of ice from minus 10 degree centigrade to plus 10 degree centigrade. So see, there is ice is present which is present at minus 10 degree centigrade. You have to convert this ice into plus 10 degree centigrade. Here water will be present. So minus 10 degree centigrade to plus 10 degree centigrade. We know very well Q equals to ms into delta T. At the same time, when ice is being converted into water, there is some enthalpy of fusion is present. Enthalpy of fusion. So that's why Y is equals to ms into delta T plus enthalpy of fusion will come. So let us see, mass of ice is equals to how many? 18 kg. Mass of ice equals to 18 kg. Specific heat of water they have given you. What is the specific heat of water means? 4.18 kilojoules per kg. And delta T value is equals to minus 10 to plus 10 is coming. So since it is the difference, there is no need, you can directly use the thing. So minus 10 to plus 10 means 20 will come. So M you know, S you know, and then T also you know. Very good. Next, what you should know? Enthalpy of fusion value. They have mentioned in the problem, enthalpy of fusion is equals to the enthalpy of fusion of ice they have given you is 6 kilojoules per mole. So 1 mole is there means 6 kilojoules. 18 kg, number of moles is equals to 18 into 10 power 3 by 18, 10 power 3 moles will come. So that's why enthalpy of fusion is equals to 6 into 10 power 3 kilojoules is the one. So substitute all these values into this thing. Y equals to 18 into 4.18 into 20 plus enthalpy of fusion is 6 into 10 power 3 kilojoules. So if you sum all those things and add one another means the value will become. So if you substitute all these values and find out means this multiplication will give you 1504 and this is 6000 kilojoules it is, not normal thing. So 6000 kilojoules plus 1504 kilojoules. Here 4.18 kilojoules. So it also will be in kilojoules. So totally it will be 7504 kilojoules is the heat supplied to the system. That is nothing but Y. So Y is equals to 7504 kilojoules. So be careful with this thing. So here Y is 7504 kilojoules. Since we got the Y value, let us see the X value. 7504 is the Y value. Since Y is equals to 7504 kilojoules. Here Y equals to 7504, X is equals to Y into 100 by 473, 200, because it is changing from 0 degree centigrade to 200 degree. So X is equals to 7504 into 200 by 470. This will be 3173 kilojoules will come. So if you find the X value, this will be 7504 into eta. You know very well, work done is equals to thermodynamic efficiency into heat supplied. So that's why it will become 3173 kilojoules. So we have identified what is X value and what is Y value. Now let us discuss what is Z value. Here the Z value is dependent on enthalpy of neutralization. X kilojoules is the heat liberated when 3 molar H2SO4 of 2 liters mixed with 5 molar NaOH of 1 liter. So 3 molar H2SO4 of 2 liters mixed with 5 molar NaOH of 1 liter. Now how to do this thing means, see, heat liberated is equals to equivalence of limiting reagent into 57.3 kilojoules. This is the heat. Let us take H2SO4 and NaOH. Let us take normality of acid is Na, volume of acid is Va, normality of base is Nb, volume of base is Vb will come. So now let us see for H2SO4, they have given molarity. So normality will be 6 normal, volume will be 2 liters. This will be 5 normal and 1 liter will come. Always remember, you are finding the equivalents means you have to find in the normalities only. So NaVa equals to 12 will come, NbVb equals to 5. This is the limiting reagent. Since this is the limiting reagent, substitute and find equivalents of limiting reagent is 5 into 57.3. 5 into 57.3 means 5 3s are 15 will come. 186.5 kilojoules is the heat liberated. So Z is equals to 186.5 kilojoules will come. Like this, we have identified the first part. This is work done from a Carnot engine. This is the heat required to raise the temperature of ice. This is the heat liberated by mixing of acid and base. Now let us see. They are asking X plus Y plus Z. Since they are asking X plus Y plus Z, you can simply take X plus Y plus Z is equals to 3173, 7504, 186.5. So 5, 3, 16, 8, 10. So one value is 10863.5 kilojoules will come. That is the X plus Y plus Z value. Like this, we can do this problem. If you like this video, click the like button, and if you want to share the video means share with your friend, and don't forget to subscribe to the channel and click the bell icon for more updates. Thank you.